material came in yesterday, so I've been messing around a little bit, get set up here for kind of a preview of how I'm gonna weld this. I wanted to make sure my dimensions and everything were correct. Already using these Fireball magnetic shop blocks a lot, so this is probably the 7th, 8th, 9th time I've used them already, so very, very happy with that purchase already. So as you can see, we've kind of got stack ups here with Fireball blocks, 1, 2, 3 blocks, and then an adjustable parallel just to get that last little 981, I think it was. So this is basically how this thing will go together. Got my piece of 3/16 plate. My friend Adam was kind enough to burn this out for me, and he had the material laying around and didn't want any money for it, so I appreciate that very much. So this is kind of what we're going to be looking at. So I'm going to put up some chill blocks of some kind on here to try and minimize distortion of the plate. Free plug for Fireball tool. They charge me regular price, and I just went on the website and bought them. So no sponsorship here, but the products are worth endorsing. They're really high quality, and like I said, amazed that I've already been using them so much. Our other piece of important material is this hardened and ground piece of 4142. This is, I think, going to work out really nicely. This is a 1-inch piece of material. It'll ride on the edge of the cross slide, or the side of the cross slide, really well, I think, and give a nice, plenty rigid enough mounting surface for this guy. Fasteners I've gone with here. Bit of discussion on the community page. But yeah, there should be plenty of meat on the cross slide to accept that hole. These are 3/8 24. I figured that would be nice and overkill. I haven't decided on the number of holes. I'm sure 2 would be more than enough for Century, but I might do 3 just because I'm already there. I guess it'd be something kind of like that, because there's overhang on this end that's not going to be touching the cross slide. So anyway, there's an update there. The first thing we need to do before we can start welding anything is on our original new wiper carrier that's going to butt up against the cross slide, we need to add that O-ring groove. And this is totally imprecise. I'm not going to be too crazy about it. All we need is a groove for the O-ring to fit in. So for a Dash 100 Viton O-ring, this should be a 121 thousandths width and then 78 thousandths deep. I'm just going to go with an 1/8 inch end mill because it doesn't really matter. Like I said, we just want this to be helpful in trying to keep coolant and oils and chips and dust from cast iron and stuff like that from contaminating the wipers so quickly. May not be strictly necessary, but although this end mill is center cutting, I didn't want to try and ramp down in there and break my little high-speed steel end mill, so we'll go ahead and drill us a pilot. So to clean up the edges and bottom and everything in there, I'm gonna use my little 90,000 RPM, it's 90, oh no, sorry, 90 PSI, 54,000 RPM air grinder. And I'm gonna use one of my little die file bits. I got all of these at one time for almost nothing. Oh, that can go somewhere else. But anyway, an estate sale grab that I got right when I first started machining, and so I didn't really know what I was getting. And it turned out, as time went on and I learned more, that I got a screaming, smoking good deal. So this is not a good way to organize them. Obviously, they're gonna get banged up like this, and sometime I will do something about it. That little guy might work. Problem with this thing is that it's noisy. Not too pretty, but it'll do the job, and I made the right choice not to bother with setting up the rotary table and getting this thing clamped in and whatever else. So, but that kind of gives you an idea of what this will look like. Sticks proud about, I don't know, maybe 15% of the thickness or 20% of the thickness of the O-ring. So not so much that the screws are going to have to really just crank down on this to get it to seal, but I think that will certainly do the job that we want it to do, which is just to kind of keep coolant and other contaminants away from our wiper. And I think, despite the time it took, this will be very well worth having. Now that we've got that done, I think we are ready to go with getting this guy clamped together and tacking it up and then welding it out. Today is tomorrow, and I think we're finally ready to weld. So I've got my blocks in here to give us the proper spacing, and then the O-ring groove has been machined in this wiper holder. So I think what we'll do is just put a couple of tacks on each end here, and then get our squares in, at least on this side. I think we can probably leave this set up just the way it is. Plate will go on top and we'll weld all three sides. So yeah, let me get geared up and we will put some tacks down. Okay, just trying to avoid putting too much heat in here and damaging my magnets. So yeah, that's already trying to pull. Since this is plasma cut, we need to get the edges cleaned up. Pickled and oiled. I think that's the only way to buy it from now on. Thank you, Adam. A few minutes over on the mill to mill down the top on each side. So I just kind of fit it. This guy is very, 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 very close to being just perfectly even with the back of the cross slide. So I just wanted to match our plate up to how this fits. So as you can see, it's now very, very close to that. We're obviously gonna weld that all together. I also went ahead and just put this flat on the table, clamped it down, and milled this side so it's flat to mate up there. And this guy is bowed out just a little bit, which is to be expected. It's had a lot of material removed and it's gotten very hot on both ends. And then just some bozo insurance to make sure I wasn't doing things differently each time. So we'll start with just some fusion tacks here. Starting to look like a thing. Our goal here is to minimize distortion of the plate. And so I took a bunch of bars of aluminum out of the drawer and just kind of packed them in there, biased toward the end that's gonna get welded, of course. And I just put the bar on here to flip it over to show you guys. But anyway, that's the plan. There's probably better ways to do it, even with just the equipment that I have, but this seems to at least tick a box in terms of making sense to me. Just having as much mass of a highly conductive metal seems to make a lot of sense. So obviously having water-cooled blocks and an argon chamber and all kinds of other stuff would be cool. But this I was able to do with 3 minutes and stuff out of a drawer I already owned, so that's how we did it. Strategy is going to be weld a bit, move somewhere else and weld a bit, move somewhere else and weld a bit, move somewhere else, weld a bit. And then once the whole thing starts to get kind of toasty, I'm gonna take a break. This doesn't need to be done on any time frame. So we're gonna give ourselves the best odds possible for it to stay square. Forgive the handheld action here, but we've done quite a bit of welding. Check out how my chill blocks are working. Obviously, this isn't the ideal way to measure temperature on a metallic surface, but in the middle of our plate, it's still just above room temperature. If I come out where I was welding most recently, it's right in this area, so that's still over 100 in the corners. But yeah, 100 isn't bad. I had maybe stopped welding and got the infrared gun after a couple of minutes at the most, 2 minutes at the most. So it's not like it's been sitting here for a half hour. So yeah, I think our plan here is working, and that guy should stay fairly straight and square. Good reminder from somebody on Instagram to put some on the outside also. Not a bad practice, although this seems to be doing a great job so far. Went in and had some dinner and it cooled off to room temperature. So we should be good to go for another little round of fun. Looks like the outside is all done. So I've been letting it cool off for 10 or 15 minutes. Good job, aluminum. Why don't we take it over to the lathe and see kind of sort of what it's going to look like. That's looking pretty good. What we'll probably end up doing is getting it mounted and then checking for clearance on the bottom here. And if it's wanting to actually ride on the way, then we'll take it over to the milling machine and just mill off until we can get it mounted, and then there still be just a few thousandths underneath it. We've also got a provision, if necessary, if we find that our screws are doing too much work against this thing kind of sagging, then what we can do on the inside ways here is basically have a little nut essentially welded underneath on each side, and then I've got that bar of Teflon that I can machine a pad on one end and then threads, you know, like a 1/2-20 thread or something like that, or maybe just make it custom and make it really fine threaded. And then we can have that Teflon ride on these two surfaces, which are not weight bearing for the compound. So those aren't precision. They're machined obviously, but not scraped. And so then we can adjust this up so that we maintain our little gap. And then obviously that Teflon is gonna take 1,000 years to cause any wear on those surfaces. So anyway, it's kind of looking like a thing finally. Seems like this setup did a good job. Keep that in my back pocket for future projects that I'm worried about warpage. Now, because this guy is going to have so much milling done on these edges, so we're gonna make that radius try and match the lathe. So a lot of this material is gonna go away. It's definitely necessary to weld on the insides, at least on the sides. I don't know that it's, maybe we'll just put a couple of stitches on the end piece. So in case you're wondering, that's my thinking, the rationale as to why we need to do this. Decide how we want to do our chilling. I think we're going to call it done for tonight. This guy's still kind of toasty, but we've got it welded inside and out. I put a couple of stitches on the back of this guy, fit it up against on the machine, and it seemed to be close to the right dimensions, so I think we're in good shape. A lot of prep to get to this point, but we're actually doing something now, which is certainly nice. This is coming along nicely. This thing is not real light, so hopefully when chips are coming off the chuck, it's not going to be too ting, 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 ting. But yeah, thanks so much for watching. I appreciate it. I will be back with more of the progress on building this because I am excited to get it done, and then we can actually install the DRO. Thanks for watching.